Hi, welcome to my channel, the Felix Nexus, and today we are going to discuss about integration. So now, in simpler way, what is integration? If you want a very clear definition of integration, we can just say of integration like integration is just the opposite of derivatives. Okay, so we know that as the derivatives helps in finding the rate of change or in the curve. For example, if I draw, wait a second, for example, if I draw, this is one line, this another x-axis, and now if I try to draw a curve, so the rate of change between this curve is known as derivatives or dx or dI. It's very common. But finding the original rate of change is called integration. And that's why integration is also known as antiderivatives. So by this we can get to that integration is, is a type of reversing the process of derivation so that we can find the original function, let it be f of x, original function of the rate of change in a curve. So it not only helps in finding the original function of a rate of curve in a rate of change, sorry, but it also helps in finding the area or volume of the infinitely small parts and also the area of the curve, a very small part of the curve. So for example, if we take that this f of x is the antiderivative antiderivative of this f of x, so we can write this as d divided by dx. Wait a second, it's not clear. D divided by dx, which is the derivative of the f of x, small f, obviously, but it is not clear, where f of x is equals to fx, and so it is correct to write that integration of of f of x, a function, dx, as dx is the constant of any expression of integration while we are integrating, equals to f of x plus c. So by this process we can prove or conclude that integration is just the opposite of derivatives. Okay, so now we are getting to some examples. So in this video I will try to explain the very first part of integration, which is the power rule. Power rule. So according to the power rule, if we are given that integration of a number, let it be x, which has the power of n, and dx, which is required for every integration, then we would get that the base x, which is the number where the number n is added by 1 divided by the same power. Okay, so the same power divided by n plus 1 plus c, which is the constant of integration. Okay, I'm repeating again. If there is a number x with the power n dx, then after integrating we'll get the number x to the power n plus 1 divided by the same power, the same exponent n plus 1 plus c, which is the constant of the integration. So now let us try to do some very basic and most important sums regarding this power rule. Now, the first question. The first question says, for example, let us integrate x to the power 5 dx. So now as we integrate x to the power 5 dx, we get that according to the power rule, x 5 plus 1, because whenever we are try to integrating the power rule integration, right, power rule types of integration, we will divide by the exponent the same, the will divide the number the same as exponent plus c, which is the constant. So the answer we will get is x to the power 6 divided by 6 plus c. So this will be the answer of the first question according to the power rule. Now next question. Now the second question states that integration of x divided, sorry, to the power 3 plus 2 dx. So now if you try to integrate this expression, and according to the power rule, we'll get that x 3 divided by 2 plus 1 divided by 3 divided by 2 plus 1 plus c, which is the constant. Now if we add 3 divided by 2 plus 1, we'll get that x 3 plus 2 divided by 2 divided by 3 plus 2 divided by 2. So you'd get that x 5 by 2 divided by 5 by 2 plus c, and thus the answer we'll get is 2 by 5 x to the power 5 by 2 plus c. So simple. And this is the fractional exponent integration of power rule. Okay, now let's get to the last example, which is, so now in the third time I will discuss about the negative exponent. For example, negative exponent of a power rule, which is, let it be x minus 4 dx. So now here many of you or many of them gets distracted, or they find it hard to do because of this negative exponent, as they think that always the exponent is not equals to 1, but it is said not equals to 1. It is not said not equals to any minus exponent. Okay, so for this we just simply use the power rule formula, and by this we get that x minus 4 plus 1 divided by minus 4 plus 1 plus c. So it will become minus 4 plus 1 equal to minus 3, and thus x to the power minus 3 divided by minus 3 plus c. Now if we just refine it, we'll get the answer as minus 1 divided by 3 x cube plus c. So here the point is to be always noted that whenever there is a negative exponent, we should not confuse it. So thanks, and please like and subscribe to my channel.